Morning, guys. Mr. Winslow here, coming to you live from my makeshift kitchen arcade instead of the regular arcade this morning. So I had a late night, wild Halloween night, lots of nephews, cute fireman costumes, and trick or treating and all that stuff. So gonna get this cotangent graph lesson done before you guys get to first period. So, um, basically what I want to do is teach you what the parent function for a cotangent looks like, and you can apply all the same transformations that you did to the other ones. Okay, so as you recall, the tangent graph, if I were to graph y equals tan x, right? We said that we basically went from negative pi over 2 to pi over 2 when we did that parent graph, right? And basically what that is you're going around like the right hand side of the circle, right? And we said, the tangent graph starts at undefined, ends at undefined, and we got those easy negative ones, 0 and ones in between, right? So when we learned secant and cosecant yesterday, they're solely based on the sine and cosine. But the thing here is the cotangent is going to be a little different to these points. We're not just going to graph this and do like a manipulation. What we're actually going to do is graph points that are kind of conducive to looking at the cotangent. So what you see on the tangent graph is, see how they went from undefined to undefined, right? We're going to do the same thing with a cotangent graph. So I want you to think real quick, okay? Tangent's undefined here and here, right? Okay. Where would cotangent be undefined? Well, cotangent would be undefined here and here at 0 and pi, right? Or 0 and 180. So what we're going to do for the cotangent, instead of just basing off the tangent, we're actually going to look at it a little differently, okay? We're going to look at one period's worth from 0 to pi. And as you recall, when we're doing the inverses, the inverse tan, inverse cotangent, remember inverse tan was like this, but inverse cotangent was like this, right? The same thing occurs here. So when we're going to graph y equals cotangent x, right? When we graph that, what I'm going to do is I'm going to go from 0 to pi, and I'm going to kind of do it by the same intervals that pi over 4. So watch what I'm going to do. I'm going to go 0, pi over 4, pi over 2, 2 pi over 4, pi, right? So notice how I went on the top half of the circle, and I just went by pi over 4s, right? So I want you to think real quick. Look at these x values right here, right? Take a minute on your own paper, and I want to see, you can pause the video or whatever. I want to see if you guys can get the y values for these, and I'm going to write them down right here as you do that, okay? So if you did it correctly, these should be your 5 coordinates, right? You get 0, undefined, right? So notice that when tangent's undefined, cotangent's, when tangent's 0, cotangent's undefined, right? And vice versa, okay? When cotangent is 0, the pi over 2, tangent would be undefined, right? So looking at that, all we have to do is graph that, and we can talk about what that graph actually looks like, okay? So if I were to graph one period's worth of that, we're going to start at 0 and go to pi, okay? Notice what I did there. I just put a pi over 4, right? And knowing that that's pi over 4, we would have to assume that's 2 pi over 4, 3 pi over 4, and 4 pi over 4, right? And I'm just going to label my y-axis like this. So 1, right? And all I'm going to do is graph those 5 coordinates, right? Including the asymptotes. So when it's all said and done, you'll notice that one period's worth of the tangent, or a cotangent, excuse me, cotangent graph looks like this. So it looks very similar to tangent, but you notice it's going the opposite direction, right? It's kind of going left to right. It's moving downwards. And yeah, we could graph, we could continue that pattern if we wanted to the other direction. And it looks something like this. This would be 2 periods worth of it. Okay. And all those same transformations that occurred to the other ones with the A, B, C, D, A being the vertical stretch or compression, B being the horizontal stretch or compression, C being the phase shift, and D being the vertical shift, giving you the midline, right? All those things are going to apply to this. But before I let you go, I just want to show you a couple characteristics here, okay? So first off, for the domain, okay? We obviously have asymptotes. We have places we can't have, right? So the domain, what we're going to say is X can't be basically any asymptote you want. And if you look, these asymptotes are pi away from each other, right? So we can actually say X cannot equal any multiple of pi. You see that? X cannot equal any multiple of pi. Because look, this is 0. This is 1 pi. This is negative 1 pi. At 2 pi, you'd have 1, and so on and so forth, right? So X cannot equal any multiple pi. What do you think the range is? You're right. All real numbers, because it goes up and down, right? As far as you want. Amplitude, what do you think about that? There it is. As you guys would say, not available or no answer, but not applicable, right, for amplitude. The only amplitudes you talk about are sine and cosine. Other characteristics we could talk about, we could say midline, okay? The midline here would be y equals 0, because you can see if I go through the middle right there is y equals 0. And finally, the period, okay? What do you guys think the period would be, okay? The period of a tangent, if you recall, was pi, and guess what? The period here is also pi. So there you have it. There's your cotangent graph, and what you're going to be doing today is you're going to be manipulating this with stretches, compressions, phase shifts, and vertical shifts, okay? So there you have it. It kind of stinks because it's almost like a different set of points, but if you recall how cotangent works in the unit circle, just go on the rainbow right here and get it going, okay? So, all right. There's my wife. Hey, wife. All right. So you guys have a great day today. Wish us luck at our appointment, and we will talk to you soon. All right.